Okay, so yesterday in our lesson, we talked about how to find the sum of the interior angles, which is listed right here. It was that formula where the sum is 180, and we take that times the number of sides minus 2. So now we're going to think about it just a little bit backwards, okay? Instead of asking you what is the sum, I'm going to give you the sum, and you have to figure out how many sides it has. So we're just going to think of this formula right here. The sum equals 180 times n minus 2, and we're just going to substitute and solve, okay? We're going to solve for n because it's asking how many sides does it have. So, and we probably already know the answer to this because we've worked with 720 degrees several times yesterday, but let's just kind of show our work on how we would actually know how many sides that polygon that has an interior angles of 720 actually is. So it says the sum is 720. Well, if you notice, the left side of our equation is the sum, okay? So we know that our sum, oops, I don't like that, oops. Okay, our sum here on the left-hand side is 720. So we are just going to rewrite this formula right here, and instead of the sum, we're going to put the number 720, and then we're just going to write everything else the same. Okay, so now we need to solve for n. Easiest way to do that, I would not distribute the 180. That 180 is being multiplied times everything in the parentheses, which means we can just divide everything by 180. Okay, and when we do that, 720 divided by 180 is 4, so we would get 4. This 180 cancels out, and we have n minus 2 is what's left, and then we would just add 2 to both sides, and we would get that n equals 6. Okay, so if we're going to classify or name it by its sides, 6 sides means that it is a hexagon. Okay, let's just do that one more time. Okay, the sum of the interior angles is 1080. So the sum is that left-hand side of our equation. So we're going to have 1080. And we're going to have 180 times n minus 2. And then we're just going to follow that same process. We're going to divide by 180. Okay, and when we divide by 180, 1080 divided by 180 is 6. These 180s over here cancel, and we have n minus 2. When we add 2 to both sides, we get n equals 8. So it has 8 sides. If we were going to classify an 8-sided figure, we would call it an octagon. Okay, so that's if it gives you the sum and it asks how many sides. Okay, this lesson is going to have a couple of different formulas that we're going to have to make sure we know how to use them differently in different situations today. Okay, second idea for today is a regular polygon. All the polygons we've talked about so far have just been polygons. I mean, nothing special about them except how many sides they have and things like that. But if it is regular, that means there's certain rules to go with it. It means that all of the sides are the same length and its angles are the same measure. So if one side is 5 inches, all the sides are 5 inches. Okay, and since each angle is the same, okay, how can we figure out how much each angle actually is? So what we're going to do is we're going to remember that the sum of the interior angles, that's that formula that we've talked about yesterday and a little bit already today, is that 180 times n minus 2. That's the sum of all of the interior angles. If we want each, okay, if we wanted to figure out how much each of anything it is, all we would do is we would divide by the number of sides. Okay, so if we want each, and again, our key word here is going to be each. Okay, so if we want each, that's when we're going to divide. So we're going to take that in regular old formula, the 180 times n minus 2, and we're to find each, we are going to divide it by however many sides there are. Okay, so let's take a look down here. I got two really pretty polygons down here. A decagon, remember a decagon means that n equals 10. You could also count. There are 10 sides on this decagon. All decagons have 10 sides. If we want each interior angle, each means we're going to divide. So we would figure out total. We would have 180 times 10 minus 2. That's our total. And then we're going to divide by 10 because that's the number of sides. Okay, and 180 times 10 minus 2 divided by 10. So each interior angle is 144 degrees. So if you come back up here and look, that would mean that this angle is 144, this angle is 144, this angle is 144, this one is 144. All the way around, all of them are going to be 144 degrees each. And if you added all of those together, it would equal our total sum. Okay, let's just look at one more quick example here. This is an octagon. An octagon means that n equals 8. Okay, so we are going to say that each of our interior angles is that total of 180 times 8 minus 2, and we're dividing by the number of sides, which is 8. We use our little calculator. We figure out that each of these is 135 degrees. So 3 right there. So I mean, this one is 135. The red's hard to see. This one's 135. This one's 135. All the way around, they each would be 135 degrees. Okay. So that's a regular polygon. We're still talking about angles on the inside. Next, we are going to actually talk about angles on the outside of a polygon. Okay. So we have angles on the outside. If you notice on these diagrams, and we talked about exterior angles with triangles, remember, last semester. I'm sure y'all remember everything I said. But the exterior angles is when it has that like weird line coming off on the outside, and it's making this angle on the outside of the polygon. That angle on the outside on this diagram, they're all labeled in blue. Okay, and the nice thing about exterior angles, it doesn't matter how many sides the polygon has, it doesn't matter any of those things. Exterior angles that are on the outside, remember interior meant inside, exterior means outside, always add up to 360 degrees. So like this guy here, 1, 2, 3, 4, has 5 sides. Those blue angles would add up to 360 degrees. Okay. This one over here also has 5 angles, adds up to 360 degrees. This one here has 1, 2, 3, 4. Exterior angles do not matter how many sides or how many angles there are, they always add up to 360 degrees. So they are always going to add to 360 degrees, just like this up here says. You just add the angle, angle plus angle plus angle plus angle, all of them added together are always 360 degrees. So we would have, in this case, we would have 2x plus x plus 67 plus 89. And since they're on the outside exterior, they always add up to 360 degrees. And then we're just going to combine some like terms here. So we'd have 3x. These guys here, when you add them together, you get 156. And then we are just going to subtract 156 from both sides, just those algebra skills that we haven't used for a little bit. And then if we divide by 3, we would get that x equals 68 degrees. So again, all I did was I added all of those outside angles up, and they will always add to 360. So that means this angle out here is 68 degrees. This guy over here is 2x, which would be 68 times 2, which would be 136 degrees. And if you added all of them up, they would add up to 360 degrees. All right, last thing, Exterior angles are kind of nice because you don't have a whole lot of calculating you have to do, generally speaking. But again, that we're going to talk about each exterior angle, just like we did when we did each interior angle. Remember, each interior angle we divided by the number of sides. Well, each, again, we're going to do the same thing. So the sum of the exterior angles, that's just all of them, is 360 every time. Okay, those are like gimme points. Exterior angles, all of them equal 360 every time. Each exterior angle just means we're going to take that total and we're going to divide by however many sides the polygon has. Okay. So the first question here, it's all just in words. There's not any pictures or anything. It says find the measure of each exterior angle, keyword each, of a regular decagon. Decagon means n equals 10. So we're just going to take our total, which is 360, and divide it by our number of sides, which is 10. And 360 divided by 10 is 36 degrees. Okay, and this last one's going to be a little bit of an ugly decimal, but each, again, each exterior means that we are dividing. So we're going to take a 26agon. Okay, so always total goes on the top, 360. We're just going to divide by 26. And this one doesn't come out perfectly. We're going to have to do a little bit of rounding. So this one comes out to 13.8 degrees. So, okay, so now that you are done, I want you to do two things. I want you to submit your completed notes to, it's called Day 2, Angles and Polygons. Completed notes. And then second thing, I want you to finish the Angles and Polygons class kick. From yesterday. Good luck.